Here we have a diagram. We have our main panel and then we have our sub panel. And of course we've got our ground wire, neutral, and these are from our phases A, B, and C. Now these are all in the same conduit, of course. Now you can see here at the main panel the neutral and the ground, they're bonded together. Now the ground is connected to either building steel or a UFR or a ground rod, and that's how you get the grounding at the main panel. Now we can see here at the sub panel that we have it grounded, but the ground and the neutral buses are not bonded together. Now the reason to do that, remember, is the safety is the ground wire. Now the farther that the current has to go before grounding out, the longer it will take to trip the breaker. So in other words, if we have a situation where down here we have a device that needs to trip because the current has gone in the wrong place, it goes here to the ground and then the ground here and then it trips. Now if we had made the mistake of bonding these together, then what happens is if there's an overcurrent, some of it goes this way and it travels a longer distance. Well, if it's traveling a longer distance and it's going this way, we don't have enough heat building up here to trip this breaker. The heat will eventually build up, but after the longer distance, because some of the excess voltage goes the longer path. So it takes the heat in the circuit breaker longer to build up in order to trip that breaker, which means more excess current goes to this device. And that could damage the device and of course cause physical harm to a person. So that's why this needs to come off. Actually, it doesn't need to come off. It doesn't need to go in there in the first place. You see, the neutral may not be grounded at the utility side since it is derived from the transformer configuration. In other words, it's not tied to the ground, and the utility company is counting on when this drop is made, this ground right here into the building, the first drop, that's going to ground that system. And that's a common utility company practice as well, that they do it that way. You may ask the question, well, what if we really want to protect this? Can't we do something that measures volts or amps and is more sensitive? Yes, and that's called control wiring and control work, and we have very expensive machinery that is often done to it. Of course, it takes a meter to read those. That meter can be built into a control panel, and again, it's very expensive to do that, so it's not done on branch circuiting and lighting typically. But that's what can be done. And also, a device like that is called a shunt, a remote shut-off device. Now, a control wiring can do it automatically, or it can be done physically by pushing a button, and we will describe how to do that as well. Of that.